A researcher collected data involving the frequency of chirps made by a ground cricket at various ground temperatures. He showed that there was a significant linear relationship between temperature and the frequency of chirps. The data used is below. Would it be a good idea to use this model to estimate the average chirp frequency when the temperature was 51 degrees? Why or why not? Okay, so let's look at the data quickly here. The data actually determines the temperatures, and they're asking whether we should use 51 degrees plugged into our model to predict the frequency of chirps. But if you look at the temperatures they used to create the model, they range from, looks like almost, things mostly in the 70s or 80s, right? Some in the 90s, right? And nothing lower than 69.4. It looks like that's the lowest value. Because of that, we're going to say no, that 51 degrees is a bad choice for this model. We should not use the model to predict for this temperature. And so that's why I've underlined why not. Let's try to explain why that's a bad idea for this particular model. Well, obviously I'm using the basis for not using this value, the fact that it doesn't fall within the range of temperatures that you use to create the model. So that's very important. Let's explain why, though, that matters, okay? So you notice the minimum is like 69.4. It looks like the maximum temperature used is like 93.3. Let me give you a drawing here to help you understand why I'm saying it's a bad idea to use 51. So imagine that we had the original data in front of us. And we decided to plot it, because remember, the data is consisting of ordered pairs, so they can be plotted on an XY grid. Here would be like the temperature axis, right? And here would be the chirps axis, or the frequency of chirps, right? Okay, frequency of chirps axis, right? So now we had on our interval, it looks like, let's say we have the number, 69, and then over here maybe the number 93, because that was the range of data temperatures they used in the model. Now maybe there, under that scenario, when you look at the particular ordered pairs, they form a shape like this, on the curve, right? Maybe we have something that kind of looks like this. So we have, a bunch of ordered paired dots that look like that, right? And so you can imagine, you can see that, gee, it'd be perfectly fine to try to fit maybe a line across these, right? We might say, well, gee, it might be that a good linear fit might be something like that, let's say, right? So there's some line where we think that the model does a pretty good job, and then, sure enough, the slope tests positive, and, we end up saying that this line is a good predictor for this data set, right? All right, so maybe that's the case, and that actually looks pretty decent, but here's the problem. That's within this temperature range from 69 to 93. If we don't have any values outside of that range, we don't know what happens outside of that. We don't know what the model would look like compared to the ordered paired actual data outside of that. As you can tell, this model is going to continue to go down like this, right? If you followed the model to its logical points, right? Because it's a straight line, it keeps going off in those directions. But here's the thing. What if the data starts to do this after this point? What if it starts to head down because maybe it's actually just a part of a very wide parabola or something, or maybe even like a logarithmic type graph, right? So that maybe it eventually begins to taper off, right, to some horizontal asymptote, right? So what will happen if we try to make predictions after 93? Well, we'll predict that the data values will, keep rising. The frequency of chirps will keep going up. But of course, in reality, they would taper off to some constant value, and we'd be way off in our predictions. And same here, maybe when we look at 59 down here or whatever, or 51 degrees down here, maybe that, we're going to predict the chirps to be here, but maybe it's really way down here, because maybe at 51 degrees, the crickets are about frozen to death, So maybe at that point, their frequency of chirps go way down because they're trying to conserve energy. So, for all we know, this would be a very poor choice to use 51. And we can't know for sure what happens because we just don't have the data here to know, because we didn't use data that was as low as 51 degrees to make predictions. To make the model itself. So it's a bad idea probably to use, a temperature of 51 in the model, given that temperature range, that was not part of the temperature range that was used to create the model. So again, under a certain span of the x-axis, data might look linear, but if you looked at it from a wider span of the axis, you might see that it actually looks something more like a logarithmic graph, or maybe like a parabolic graph or something like that. So you have to be very careful when you try to make predictions outside of the range of x values that were used to create the model. So in this case, because 51 degrees is pretty far away from our lowest temperature that we used in the model, I'll go ahead and say that it's probably a bad idea to use 51 degrees.